Now let us consider what is called as co-normal points of a parabola. For this, let us consider some point, say h comma k, which is given to us, and a standard parabola. So the standard parabola, let the equation be y square is equal to 4ax, and some point is given to us, that is h comma k, not necessarily on the parabola, it can be anywhere. So from this point, which is h comma k, we want to find out how many normals can be drawn to the parabola, right? So the answer is that maximum 3 normals can be drawn to any parabola from any point. That means the point may be situated in such a way that we can draw 3 distinct normals. Say as an example, we are showing these normals here. There can be one normal like this, and there can be just closely situated another normal like this. But whereas if you consider a point which is very close to its vertex, something like this, in that case we can draw only one normal. As you can see, there is no space to draw the other normals. So this is how we get different possibilities of drawing the normals. Now the points which are the feet of the normals on the parabola, okay, so that's the points where the normals meet the parabola, they are called as co-normal points. So these A, B and C are called as co-normal points. Looking the other way around, these are the points such that if we draw normals through these, then the normals meet at a single point, which is h comma k. Now if we consider the equation of the normal to the parabola, as we have seen previously, we had derived that the equation of any normal is given in its slope form as y is equal to mx minus 2 times am minus am cube, right? So this is a cubic equation in m. So naturally it will have 3 complex roots. And from the theory of equations, we know that for a cubic equation, either we can have all the 3 real roots, or we can have 1 real root and 2 complex conjugate, that is the 2 roots involving the imaginary quantities. Okay. So therefore this is what it connects to the normals shown here on the left side. 3 real roots indicates that there are 3 different normals possible to be drawn from the point h comma k, or only one normal, only one real normal that can be drawn from the given point h comma k, like that. Okay, so that is how the number of normals is decided. Now if we substitute x and y with the point h comma k, that means in place of y we write k and in place of x we write h, so we get this particular equation. So therefore we get am cube plus h minus 2a times m plus k is equal to 0. Right. Sorry, it has to be the other way around because we are taking the terms on the left hand side. It should be 2a minus h times m. Now if you observe from the theory of equations, the sum of roots, that is if we consider the 3 roots to be m1, m2 and m3, then the sum of roots will be given by 0 upon a, which turns out to be 0, because this 0 stands for the m square coefficient, but m square term is absent here. So therefore the sum of the 3 roots of this cubic equation turns out to be 0. So that's an important conclusion. So whenever there are 3 distinct real normals that can be drawn from a point, then sum of their slopes will always be equal to 0. Now related to this, there are a couple of properties which are derivable, so we will just go over those properties. of co-normal points and the normals. Alright, the first one is the sum of y coordinates of feet of the three normals drawn to the parabola from a point is 0. So that means if we consider a parabola and there are three normals that are drawn from a particular point, then the 3 feet, that is the 3 points, the co-normal points, the sum of their y coordinates is always equal to 0. Secondly, for these 3 points, if we join and make a triangle, the centroid of that particular triangle formed by the feet of the 3 normals lies on the axis of the parabola. So what it means in other words is the y coordinate of the centroid of that particular triangle is 0, and which directly comes from the first property because sum of the y coordinates of the 3 feet is 0. And lastly, here we have a condition or a criteria, that is, how do we know from a particular given point whether we can draw 3 distinct normals or only one normal. So the condition for that is that if the point is h comma k and if the parabola is a standard parabola, then the condition that should be satisfied is h should be greater than 2 times a. So if this condition is satisfied, only then we can draw 3 real normals to the parabola, otherwise only one normal can be drawn. So that's the condition.